So we are going to be graphing functions. This says identify the parent function and transformations from the parent function, then graph. So you have to identify that stuff, then graph. It's all part of it. So this function, what is this parent function called? Absolute value, absolutely. So it's absolute value. So f of x equals the absolute value of x. Then I need you all to become an absolute value. We'll wait for everybody to become an absolute value. That's a really weak absolute value, and so you need to be a proud absolute value. Thank you very much. Okay, so here's my absolute value. How many anchor points does an absolute value function have? 3. It's either 3 or 5. If you can get away with, like if 3 is, if 3 works, which it will on here, we're fine, and then some of them will have 5. So I'm going to actually put them on here. I mean, I'm not plotting them, but if I do that, I know where they are. That's good enough, and I'm going to kind of mark them off as I go. Then I'm going to decide how many transformations do I have. How many transformations? 3. Okay, so I have 3 of them. I have a negative. That negative I know is a reflection. It would be a reflection in what? The x-axis. Good. Last period, a couple people said y-axis, and I was like, yes, good. We graphed the whole thing, and I was like, something is not right. And I was like, y'all let me do this whole thing. Somebody was like, I thought I was right. If you're questioning what I'm doing, please ask me, because it's one of 2 things. I could totally be wrong, which doesn't happen a lot, but I'm definitely not perfect. Well, I mean, it happens more than it should probably, but I'm not going to teach you stuff wrong. Or you're obviously comprehending it wrong, and I need to fix it. Okay, so either way, it's worth a question. Okay, all right, and I never get offended if you're questioning what I'm doing, because yeah, I know I'm not perfect. All right, so then this 1, what does it do? To the right 1, and the 7 up 7. Okay, so here's how these anchor points work. I'm going to start, and the more consistent you are, okay, oh, this is the other thing, because last period when I said, okay, let's talk about the transformations, and somebody said, you go to the right one. I was like, yes, you do, but always go from left to right, because when you do your transformation, the order does matter to an extent. The exact order could be different for different people, but your translations, your left, right, up, and down, have to come last. If you do them first, it doesn't work. So if you always go left to right on your function when you're listing them, your translations will be at the end every time, and you won't, risk that. Okay, so I'm going to start with this -1, 1 point. So on my graph, I'm going to go to -1, 1. I'm not plotting the point. I'm just putting my pencil there for a second. Okay. Then from here, I'm going to do the transformations. From -1, 1, I'm going to reflect in the x-axis, so I end up down here. Then I move to the right 1. And then I go up 7. 1, 2, 3, 4, 5, 6, 7. And I'm right here. Okay? And so that's why I'm marking it off on here, because just because I have 1 point, I want to make sure that I don't do the same point again or get confused. So now I'm going to be at 0, 0. Put my pencil here. You reflect in the x-axis, you don't go anywhere. Then you move to the right 1, and you go up 7. That's your new 0, 0 point. Oh, I also have, if you need, not only do I have pencils back there, but I also have little pencil top erasers. So like if you've used up all your eraser or whatever, they're back there if you need them. All right, and then I'm going to do 1, 1. So I start here. I'm going to reflect in the x-axis. Then I move to the right 1, and I go up 7, and I'm right here. And then that's all I need to make that. Your ID makes a phenomenal straight edge, and it should be around your neck, so you can just kind of plop. You don't even have to take it off. You can just plop it up on the table, and you got a straight edge. And I'm going to cheat with my little straight edge up here. All right, we good? Okay, so domain, is that pretty easy here? Yes, -infinity to infinity. My range. Is my range from 7 to negative infinity? No. Where does it start? Negative infinity, bottom to top, least to greatest. Holy cow. Negative infinity to 7, and then I include that. My X-Intercepts, you do not get to guess off of your graph. Okay, if it's not a point that you plotted, you just sketch that by hand and no. Okay, so you have to figure them out. Algebraically, how do I figure out an X-intercept? Y equal to 0. Okay, so that means I get 0 equals negative absolute value of x minus 1 plus 7. I subtract 7 from both sides, so I get negative 7. Oh, actually, I could do that, but that's not what I wanted to do. Since this is negative, I want to move it over there. Makes my life a little easier. So I get absolute value of x minus 1 equals 7. Then I have two little equations I have to set up. I'm going to have x minus 1 equals 7 and negative x minus 1 equals 7. Oh, gosh. What the heck is my problem today? Okay. Negative x minus 1 equals 7. So then here I get x equals 8. And here I'd get x minus 1 equals negative 7. So x equals negative 6. Okay. All right, so then it says X-intercepts. So do I write them with the little curvy brackets or are they ordered pairs? Ordered pairs. Intercepts are ordered pairs. So my X-intercept is negative 6, 0. And 8, 0. And you can see if I guessed off my graph, I'd be way off because this is over 9. Because I guess I was just, but that's okay. Like we plotted some specific points. It's close enough, but not close enough to guess. Even if you were dead on to 8 and we're like, well, mine was perfect. Great. You still don't get to do it that way. Okay. We good? Now, my Y-intercept. I don't have to plot that. I have to plot it. I don't have to solve for it because it's a point on my graph. It's at 0, 6. So we're good. Do I have any critical points? Yes. I have one, and it is a what? Absolute maximum. And it is at 1, 7. Is it increasing anywhere? Yes. This is all increasing. This is all decreasing. Meaning my y values are increasing. My y values are decreasing. I write intervals of x. So it is increasing from negative infinity to here, which is at 1. Then it's decreasing from 1 to infinity. As x approaches infinity, what does f of x approach? Negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. Good deal. All right, any questions at all? We good? Awesome. All right, so let's look at number 2. What is this parent function called? Quadratic. Okay, so that is f of x equals squared. Show me your best quadratic. Good job. Okay. And how many parent functions? How many anchor points does it have? 5. And so this is how you can remember. So if you go, oh, well, it has 3. Well, yeah, those are the same 3 as the absolute value, right? And that's fine to draw a line through, but I need a couple more to help me get where my curve is really supposed to be. So I actually have 5. Okay. And so then my transformations, how many do I have? Just 1. It's being multiplied, so it's either a compression or a stretch. First of all, is it horizontal or vertical? Horizontal. And is it a stretch or a compression? Stretch, because x does what? Lies. So it's a horizontal stretch by 4. Everybody good so far? Okay. All right, so I'm going to start always left to right. I mean, the more consistent you are, the less confused you're going to be. So I'm going to start with this point. So at this, now is when I have to say, okay, now what is that actual point? What would that be? Close, but yeah, it's okay. Negative 2, 4. So I'm at -2, 4. That's where I start. I have a horizontal stretch by 4. Horizontal means I'm dealing with x. My x value is a -2. I multiply the x value by 4, so that becomes -8. So I go to -8. You do not count 8 from there, and we were already at 2, so you have to go 6 more to get to -8, and that's your point. Okay, so be careful. That's one mistake that happens a lot when you're doing the stretches and compressions, is that you count from there, and you just got to know that the value is what's changing. Okay, so then my next one is at -1, 1. I start here. The only thing I have is a horizontal stretch by 4. My x value is -1. Multiply that by 4 becomes -4. That's my point. 0, 0. Well, horizontal stretch doesn't do anything, so I'm still at 0, 0. Now I have 2 more anchor points, and I have 2 options here. I can plot them just like I did these and transform them, or I know that this parabola has symmetry, that this has to be, symmetric to the other side, so I could just use my symmetry. If from here to here I go up 1 and over 4, I have to go up 1 and over 4 this way. To get from here to here, I have to go up 4 and over 8, so I go up 4 and over 8 this way, and I'm good. Okay? So either way is fine, just got to get them in the right spots. Then you just do your best to get a general curve. You know it's not supposed to be pointy or anything because it's a parabola. It's not an art class, but you have to make an honest effort and not just throw something down on the paper. Okay? Any questions at this point? All right, my domain and range. Okay, so domain's pretty easy, all of it, so -infinity to infinity. Is my range infinity to 0? No, it is 0 to infinity. Least to greatest, left to right, bottom to top. My x-intercept I plotted, it's 0, 0. That's also my y-intercept, so that's nice. Do I have any critical points? Yes, I have an absolute minimum at 0, 0. And I am increasing from 0 to infinity and decreasing from infinity to 0. What did I do? Oh, goodness. See, I was seeing if you're paying attention. Thank you for correcting me. Good job paying attention. I was testing you. Y'all, that's like almost never true when I say that. All right. Yeah, I just didn't know it. That was the thing. I didn't know I was trying to do that. In behavior, as x approaches infinity, f of x approaches infinity. And as x approaches -infinity, f of x approaches infinity. Yay. We all good with that? Awesome. Let's look at number 3. What is this one? Square root. Okay, so f of x equals square root of x. Give me your best square root of x. It's this one, like I'm a little teapot, right? Everybody become a teapot. Your teapot's going the wrong way. There you go. Okay. So, looks like this right here. How many anchor points do I have? 3. Yeah, there's no need for 5. I mean, you can do more than 3, but we don't need that. So, there's my 3. How many transformations do I have? 3. Okay. So, this 3, is that vertical or horizontal? Vertical. And it's a vertical what? Stretch. Good. Vertical stretch by 3. Because Y is a good guy and he doesn't lie. All right. Net negative, that is a reflection in what? Good. Reflection in the y-axis. And then that 2, right 2. Okay. We good with all that? Alrighty. So, I'm going to start off with my 0, 0 anchor point. So I put my pencil on 0, 0. Vertical stretch doesn't do anything. Reflection doesn't do anything when you're at 0, 0. So I just go to the right 2. That's my new 0, 0 point. This point is at 1, 1. So I put my pencil there. Vertical stretch by 3. So that means my y value is 1. I multiply it by 3, I get 3. Move up there. Reflect in the y-axis, end up here, and then move to the right 2. And I actually end up right back where it was. All right, so then what's this anchor point? What's this point? What would make sense? 4, 2. Okay, because that would be the next number you could put in to get something decent. So I'm at 4, 2, right? Vertical stretch by 3, so my y value is 2. Multiply by 3, I get 6. Reflect in the y-axis, so I end up over here. And then I move to the right 2. And then because I know the general shape of a square root, and it has been reflected and stretched, so it looks a little weirder, but it looks something like that. All right, so my domain, negative infinity to what? 2. My range starts where? 0 and goes to infinity, and I include the 0 and the 2. My x-intercept, I plotted that point, so I'm good. It's at 2, 0. My y-intercept is not a point I plotted. On my graph, it looks like it goes through 0, 4. Does yours look like it goes through 0, 4? Okay, exactly at 0, 4? No, because I'm thinking mine's probably wrong anyway, because I sort of missed that point right there. So probably not good. But either way, I shouldn't be guessing off my graph, right? How do I find my y-intercept? Plug in 0. So I need to find f of 0. That's going to equal 3 times the square root of negative x, not x because that's 0 now, 0 minus 2. All right, well 0 minus 2 is a negative 2. You make it negative, it's positive, so you get 3 square root of 2. And so my y-intercept is 0, 3 square root of 2. Okay, we all good with that? All right. Do I have any critical points? Yes. I have an absolute minimum at my x-intercept, which is 2, 0. Is it decreasing anywhere? Yes, everywhere, right? So from negative infinity to 2. Oh, I put increasing. I said decreasing though, right? Okay, sorry. So it's not increasing anywhere. All right, negative infinity to 2. That's where it's supposed to be. Okay, so my end behavior says as x approaches infinity. Does x approach infinity? No. So we're going to mark out the infinity. What does x actually approach? 2. And as x approaches 2, what does f of x approach? 0. So as x gets closer and closer to 2, y gets closer and closer to 0. As x approaches negative infinity, f of x approaches infinity. Good deal. All right, what questions do you have? Anything? All right. Let's look at number 4. What is this one? Cube root. Okay. Cube root f of x equals the cube root of x. Become a cube root. Sure, walk like an Egyptian. Okay. There we go. All right. So it's like this. It's like the cubic that's been laid down. How many anchor points do I have here? 5, because 3 is not going to be enough to help with that curve. So I have these 3 for sure, but then I have 2 more out here. How many transformations are happening? 3. Okay, so I have 3. That 2 is a what? Horizontal compression. Good, because x lies, so it's a horizontal compression by 1/2. The 1 means we go left 1, and the 4 means we go up 4. Okay, everybody good with all that? Okay, so for our anchor points, we know that this is 0, 0, 1, 1, negative 1, negative 1, but I need to start over here. So what would make sense for that to be? 2 and 8, but then double check that you get them in the right order. And that's where this picture kind of comes in handy also. Is it negative 8, negative 2, or negative 2, negative 8? Negative 8, negative 2. And you can see that you go farther left than you do down. So it can kind of help you. That's another reason you have the sketch. So I'm going to go to negative 8, negative 2. That's where I'm starting. I have a horizontal compression by 1/2. So I multiply my x value by 1/2. So my x value becomes negative 4. Then from there, I move to the left 1 and up 1, 2, 3, 4. Make sense? Okay, so then I'm going to move to negative 1, negative 1. Put my pencil there. Horizontal compression by 1/2. My x value is now 1/2. Then I move to the right 1 and up 1, 2, 3, 4. Then I'm going to do 0, 0. Ooh, goodness, leaning on the board. Okay, 0, 0. Put my pencil here. I'm going to, no, horizontal compression doesn't do anything. I move to the left 1 and up 1, 2, 3, 4. Okay, so then I'm going to go to 1, 1. 1, 1. Horizontal compression by 1/2. X value is now 1/2. Move to the left 1 and up 1, 2, 3, 4. Then I have one more point. What is this one going to be? 8, 2 is where I start. Horizontal compression by 1/2. X value becomes 1/2. Move to the left 1 and up 1, 2, 3, 4. Everybody good with all that stuff? Yes? Okay, so then I'm going to just sketch this in like so. Good. Okay. Any questions about any of that stuff? You gotta let me know if I lose you somewhere. Okay, so my domain, pretty easy, negative infinity to infinity. My range, also negative infinity to infinity. X-intercept, there's not one that I graphed, but is there one? Yes, because it's eventually going to cross the x-axis. I also know it's also going to be negative, so that can help me make sure I get my right number when I actually solve it. So I need to set this equal to 0. So 0 equals the cube root of 2 times x plus 1 plus 4. Then I need to solve for x. So I'll subtract 4 from both sides. Negative 4 equals the cube root of 2 times x plus 1. What would I do next? I can distribute, but I also don't have to, so I'm not going to. If you do, it's not wrong. It's not wrong if you do it. So I'm going to cube both sides. What's negative 4 cubed? Negative 64. Good. So that's going to give me 2 times x plus 1. And again, you could distribute, but you don't have to. Because right here, I can just go ahead and divide both sides by 2. I can get a negative 32 equals x plus 1. Then negative 33 equals x. And it comes out to be a nice, pretty number. It's just negative 33, 0. And I know it's got to be negative because it should clearly be over here from what I know about my graph. Okay. Y-intercepts. Well, clearly I have one, but I don't get to guess off the graph, so I've got to figure that one out too. That's when we find f of 0. So f of 0 is the cube root of 2 times 0 plus 1 plus 4. So 0 plus 1 is 1, times 2 is 2. So that leaves me with the cube root of 2 plus 4. Does that become the cube root of 6? No. Is there anything else you can do with it? No. So don't try just for the sake of trying because you will be making up math. Your answer is 0 cube root of 2 plus 4. And my guess is if I had to estimate the cube root of 2 plus 4, it would be about 1, 2, 3, 4. It's just a little bit more than 5. Right? Because you can solve that on your graph. But that's irrelevant. That's your exact answer. Okay? We good? Do I have any critical points? Yes. This right here, what's this called? Point of inflection. Good. point of inflection. And that is at -1,4, I think. Because it doesn't change. So it's increasing this whole time, so it doesn't change direction. It doesn't change from increasing to decreasing. It just changes the shape. It's just kind of where the graph speeds up a little bit. And it's just a little wiggle. Okay. All right, so increasing, well, I just said it. It's increasing the whole time, right? So -infinity to infinity. And it's not decreasing at all. As x approaches infinity, f of x approaches infinity. And as x approaches -infinity, f of x approaches -infinity. Very good. All right, what questions do you have? Okie dokie. Then I think number 5 is the exact same as another one. So, which time do we have left? Yes, exactly. I know. I think I'm a victim of cutting and pasting. And I want to jump to number 7. We'll come back to number 6 if we have time. Which we very well may have time. Wait, we did 1, 2. Did we do 3 and 4? That's what we just did. Okay, I'm sorry. I have different pages up here. I'm getting and they don't even match some of these, so I don't know. Okay, we'll go to here. So we only skipped 2 problems, right? Okay. And I was going to obviously skip the one we just did the same. You all right over there? Okay. All right, so my parent function, what is this? Cube root. And we did already do a cube root, but we're going to do another one. Cube root, and this is f of x equals the cube root of x. And I've already made you walk like an Egyptian, so we'll just draw it in here. And I have how many anchor points? 5. And see how you didn't have them memorized. And I said, what makes sense here? And you were able to come up with what made sense? That's how it's way better to understand the concept and be able to get to the end result than just have everything in the world memorized, because that doesn't work for most people. How many transformations do we have? 3. Okay, so I have a negative. That means it's a reflection in what? Y-axis. Very good. The 1/3 is a what? Good. Horizontal stretch by 3. And then the 4 means I go up 4. Okay. Everybody good with all that? Awesome. So my anchor points, my first one here, that's at where? -8, -2. Okay, and there's 10 boxes if you haven't figured out, so you don't have to count all the way over there. -8, -2. So from here, I reflect in the y-axis, so it ends up over here, all right? Then I have a horizontal stretch by 3, so my x value becomes 24, so it's going to be way out here. And then I go up 4, so it's going to be like right around here. You don't, if it goes off by more than 1 or 2 in the end, you don't plot it, okay? But if it, but sometimes we still need to think about the fact that it's kind of way out here once we actually go to draw it in. Okay, so then I'm at -1, -1. So I want you to get as many anchor points on this graph as you can for this on your own. I'll give you a couple minutes to plot those. Y'all aren't missing anybody, right? Nobody sits there. Okay, so those are the only 3 that actually fit on the graph, right? So that's fine, but we still want to think about where those others would be, or at least where one of them is, like the first one we thought about, because a lot of things could happen here. I could just draw a straight line through those, but that doesn't make any sense, right? And if you didn't draw this, and you don't have cube root and cubic straight in your mind, or sometimes even if you do, you're likely to draw in a cubic, which makes no sense, right? But we had this 24 point out that it was like here, let's see. Let's just kind of get that again. We were at -8, -2. We reflected in the y-axis, horizontal stretch by 3, and then we went up 4. So it's like right here. That means if I was to actually use this point, I would come in, this almost comes in almost as a straight line, right? So it still helps you with the shape. So you're not coming from down here. That wouldn't make any sense. You still have to think logically about what's happening. It's not a straight line, but it starts to straighten out a lot, right? And this mine kind of looks like a straight line right here and not over here. That's not the end of the world. As long as you know it's not an actual straight line, you're fine. Okay? Everybody good so far? Okay, and you got to make an honest effort to make the wiggle. Remember, not an art class, but you got to make an effort. Okay, so my domain, -infinity to infinity. My range, -infinity to infinity. My x-intercept, well, I know my y-intercept. Let's go ahead and put that. That's at 0, 4. I don't have to do anything there. But I do have to find my x-intercept, which I'm going to have one and it's positive. It's over there somewhere. And I know it's farther out than x being 24 because there I was still like up here. So I'm going to set this equal to 0. So 0 equals the cube root of -1/3 x plus 4. So once again, I subtract 4 from both sides. Then the next thing I do is cube it. So I will get -64 equals -1/3 x. So when I multiply the negative times the negative, it's going to become positive, which I already knew, so that's good. I got to do 3 times 64. Here's how you can do it simply. What's 3 times 6? 18, so it's 180. And then 3 times 4 is 12. That means x is 192. So this is 192, 0. Okay. I have a critical point, this thing right here. What's it called? Point of inflection. And that's at 0, 4. Is it increasing anywhere? No. It's decreasing everywhere, so it's -infinity to infinity. As x approaches infinity, what does f of x approach? -infinity. And as x approaches -infinity, f of x approaches infinity. Good deal. All right. What questions you got? Anything? Okie dokie. All right, let's look at number 8. This one is a what? Quadratic. Okay, so we're going to do another quadratic. Which I know that you have graphed quadratics differently than this, using like the vertex form. I couldn't even think of it. Like there's vertex form, there's other ways to do this, but we're going to be consistent with all of our transformations. There's nothing wrong with doing it. You should know how to do it with vertex form or whatever. We're just kind of looking at transformations globally now, okay? F of x equals x squared, and then we all know what a quadratic looks like, but how many anchor points does it have? 5, okay? 5 of them. And how many transformations are happening? 4. Good. So I have 4. I have the negative. That's a reflection in what? In x. Good. In the x-axis. And then the 3 is a good vertical stretch by 3. The 4 means I go right 4, and the 6 means I go up 6. We all good with all that? Okie dokie. So I'm going to start out here. What's this point? -2, 4. Okay, so I'm at -2, 4. I start here. I reflect in the x-axis, so I'm down here at -4. Vertical stretch by 3, So my y value becomes 12. So I am off the graph a little bit, but I'm not stopping just yet. I move to the right 1, 2, 3, 4. Oh God, I can't even count. Where am I? 1, 2, 3, 4. Okay. And then I go up 6. Well, if I'm at negative 12 and I go up 6, where am I going to end up? Negative 6. So that's actually a point on the graph. You can't skip that point. If your anchor points fit on the graph and you don't have them, you're going to get points off because it's going to affect the shape of what you have in the end, okay? So then I can go to negative 1, 1. I reflect in the x-axis, vertical stretch by 3, go to the right 4, up 6. So I'm at 3, 3 then. Then I'm going to start with 0, 0. The reflection in the stretch does nothing at 0, 0, so I just go to the right 4 and up 6. I have 2 more points. Do I have to count them like I did? Or can I use symmetry? You can use symmetry, or you can do what we just did. It doesn't matter, either way. Some people like to go ahead and transform all of them so that they don't mess anything up. That is totally fine. Just make sure you're using your symmetry right. And then this is what our graph looks like. Oh, but a whole lot better. Sorry, I'm all like sideways and stuff. Mine looks like an ironing board. Yeah, that's what I was going for. I was drawing a pretty spaceship. All right, so let's just look at the intercepts here. Well, I definitely don't trust my intercepts with my hot mess of a graph up here. So I need to set y equal to 0. So I'm going to have 0 equals negative 3 times x minus 4 squared plus 6. Now with a quadratic, what do we normally do? Factor. But I don't have, if I want to factor this, I'm going to have to like multiply it out to factor. I definitely don't want to do that. So I can solve it just like I would solve an equation. So I'm going to subtract 6 from both sides. So we get negative 6 equals negative 3 times x minus 4 squared. Then I'm going to get, then can I take the square root here? Nope. I got to do what? Divide by 3. So I'm going to get 2 equals, and then I have x minus 4 squared. But now I take the square root of both sides, right? And when I do that, on this side, I get x minus 4. What does that equal? Plus or minus, he's not going to be in math jail, plus or minus the square root of 2. Because I can clearly see on my graph that I have 2, right? So now when I add 4 to both sides, I will have 4 plus or minus the square root of 2 equals x. Now, if that wasn't a square root, if it was just 2, then I would literally add 2 and literally subtract 2 to get my 2 answers. We understand that, right? But since it's a square root, I can't do anything. And so my x-intercepts I have, and we can just do 4 plus or minus the square root of 2, comma 0, and that'll take care of both of them. What about my y-intercept? Do I know that? Do I have one? Yes. So I have to do f of 0. That's equal to negative 3 times 0 minus 4 squared plus 6. So negative 4 squared is positive 16. So I have negative 3 times 16 plus 6. It's negative 3 times 16. Okay, good. So it's a negative 48 plus 6. So this is at 0, negative 42. What questions do you have? Can you graph? Yes. Okay, so your assignment is in Delta Math. Some of it's a discovery. Some of it doesn't let you go on until you're right, and you actually move the little points on there. Move the anchor points are there for you. Pick the first one and move it just like we did, and it should move right along with you. You literally like click on it and move. You can do it with a mouse. It doesn't have to be a touch screen. And then next week we'll graph some more, like you'll literally graph on some paper too, but this will be a little practice before then. Okay, we good? Awesome.